Hello all, good morning. So real quick, we're going to finish up section 9.1, looking at what kind of the next week needs to look like. We're going to test next Wednesday. We're going to do 9.2 on Wednesday the 15th. Friday we'll do 10.1. Monday we'll do 10.2. Review will kind of be on your own. I'll post a few things for y'all to work on ahead of time, and y'all can come ask me questions and we'll chat about it. All right, so we're just going to go through, we're going to find a couple of confidence intervals, and then we're going to talk about how to find the z-scores at the confidence intervals, and then I'll show you just kind of some common, basically some common z-scores or z alpha divided by 2 that you'll need when we're trying to find required sample size, which is really why you end up needing that z alpha divided by 2, is because we're eventually going to estimate sample size. Okay. All right. So we have a survey of 80 car accidents in Collin County that show that 46 were alcohol related. Construct a 90% confidence interval estimate of the true proportion of alcoholic related accidents in Collin County. All right, write a sentence to interpret the interval. What is the point estimate and the margin of error? Well, your point estimate just flat out is going to end up being your 46 divided by 80. Okay? All right, so looking at my calculator, constructing my confidence interval. Let's see how I can make the calculator look a little better. There we go, better. All right, so now we're going to go to stat. We're going to go over to test. Remember, we're going to 1 proportion z int, so A. We're going to type in, remember, our x value is 46, and our n value is 80, because remember, we're talking part over whole here like we always do. And then we want a 90% confidence level interval, so make sure you change that to 0.9. Run your calculation. So we have, it gives us our p hat and our n. Our confidence level interval is 0.48409, comma 0.66591. So that tells me that we are %90 confident that the proportion of, well, the true proportion of alcohol-related accidents in Collin County is between 0.48409 and 0.66591. Okay. So it also says our p-value. Our p-value here is actually a really nice decimal, which is rare. 0.575 is our p-value. Now they want our margin of error. So remember, to find our margin of error, we were kind of talking about this last time. If you think about your confidence interval, right, on a number line, and we have 0.48409 and 0.66591. All right? Our p hat, and this is our confidence interval. Okay, labeled CI right there. Our p hat is going to be dead middle, whatever that middle value happens to be. So the easiest way to find our margin of error, pull up another sheet. Is to either do, to find your margin of error or your MOE, is to either do your upper bound minus your p hat or your p hat minus your lower bound. Okay, so we can do 0.66591 minus p hat, which is 0.575. Okay, and I get 0.09091. And if I want to double check myself, if I add that to my lower bound, 0.48409, I should get my p hat because it's flat dead in the middle. Those are equal. Use some geometry notation for you. All right. Critical value. Critical values are numbers that separate sample statistics that are likely to occur from those that are likely to occur. Yippee. All right. We'll end up using a lot of critical values when we do hypothesis testing. Okay. So finding a critical value that corresponds to a 90% confidence interval. Bottom line, you're finding the values right here. Does that make sense? And basically, to find your alpha, your confidence interval, as we talked about before, is equal to 100 minus alpha. Okay? Sorry, I'll switch to a different pen. I know that might be hard to read in some cases. Okay, so 90 means alpha is 10, which means alpha over 2 is 0.05. Okay? The way I can find this z over this z divided by 2, and what we mean here when we say z divided by 2, we're talking about the z-score right here. That happens right here in the standard distribution, which has a mean of 0 and a standard deviation of 1. Okay, so if alpha is 0.10, then alpha over 2 is 0.05. But if I want to find z divided by 2, I want one or both of those scores, usually keeping it positive is better. All right? But what you're going to end up doing is you're going to go to second distribution. You're going to go to second distribution, inverse norm. You're going to type in 90%, a mean of 0, standard deviation of 1, and you're going to do the center. If you do the left or the right, that's fine too. But we're going to do the center just to pull up both of them. And that gives you 1.648 or 1.645 for 3 decimal places. Also, these are very common numbers that you'll see almost anywhere. Our alpha divided by 2 here is 0.025, 0.01, 0.005. We're just taking our alpha value and dividing it by 2. Now, there's actually a table of these, and these might actually be on your formula chart, but we'll look at it next time. But that would not be bad to take a screenshot of, but that gives us some very common z-scores. Okay, so if I'm looking at 95, that's 1.96. I knew statistics students at one point that had these memorized. 98 is 2.33 and 2.58. All right, going ahead, and so I've gone ahead and using that screen that I showed you, I filled in my z alpha over 2, The whole reason we want to do this is, again, we want to know that z-score so we can, if I want a 90% confidence interval of blah, blah, blah something, and my proportion is this thing, then what does my sample size need to be? Okay? All right? So looking at this. All right, so this is how we solve sample size. Okay? If you're given P and Q, that's great. And E is your margin of error. All right? Then we want to know what our sample size could be. P is your prior estimate, or a P hat, and Q is always 1 minus P, P hat and Q hat. Okay? Now, if you do not know P and Q and it's not given to you, then you're going to use 0.25. Okay? Notice down here, because we're talking about sample sizes, we're usually talking about people. We don't do partial people. Okay? So you are going to round up to the next whole number, regardless of whether it's 0.1 or whatever. Round up to the next one. Sociologist wants to determine the percentage of residents in America that only speak English at home. What sample size should be obtained if she wishes for her estimate to be within 3 percentage points with a 90% confidence interval? So we were just given the margin of error, which is, 0.03. Okay? Assuming she uses the estimate from the Census Bureau of 82.4%. Okay? So this means that P hat is 0.824. Okay? We're talking a 90% confidence interval, which makes our Z alpha over 2, using our table, 90%, right? Yep. 1.645. Okay. And then remember, Q hat is 1 minus P. All right. So if I'm plugging this in to find N, and I'll just do it on a sheet of paper below because I write too big. Let's pull that all of my. N equals 0.824 times 1 minus 0.824. Okay, I'm plugging directly into this formula here. Times 1.645 divided by 0.03 squared. That's what it should be. All right. That works. Three. Okay, so that gives us a sample size of 437. So N needs to be 437 because we're going to round up to the nearest person. Okay. All right. All right. Determine the point estimate of the population proportion, the margin of error for the confidence interval, and the number of individuals in the sample with the specified characteristic of X with a sample size of N. Okay? All right. So if we're looking, the N is here. The first thing we want is we want the point estimate. Okay? So I want to know what is halfway in between 0.51 and 0.051 and 0.074. Okay. All right, and p hat's not that bad to find. Okay, we're not given a percentage here. No, we're not. Okay. All right. So, if my lower bound is 0.051 and my upper bound is 0.074, right? How far is that between them? And we want to know what halfway is. Okay. So the distance between them is 0.023. Okay. So half of that would be .0115. Excuse me. There you go. So now what should happen is I should be able to find my p hat, take my lower bound and add 0.0115. And some of this is just a little bit of logic and number sense, right? 5. Okay. I think that's my p hat. But I'm going to double check it by adding 0.0115 again to make sure I got the end of the confidence interval, which I did. Okay. So this here is my margin of error. My 0.0115 is your margin of error. Okay. Your p hat is 0.0625. Well, using some logic, what was the other thing they asked? We found the point estimate, we found the margin of error. They want the number of individuals in the sample. Well, if we know that p hat, which is x divided by n, and we know p hat is 0.0625, and n is 1120, then we can find x easily. Yeah, you should have gotten 70. Okay. Okay, so those would have been your three answers. Your MOE is this, the p hat is this, your x value is 70. All right, let's go to the last one. Okay, and we're still going to have to use the formula we had before. Okay, an urban economist wishes to estimate the proportion of Americans who own their homes. What sample size should be obtained if he wishes to estimate to be within 0.02. So I'm going to stop there. All right. My MOE, or my E, my margin of error in your formula, is 0.02. Okay. My Z alpha over 2 is still my 90%. He still says 90% confidence. So we're looking at 1.645. Okay. Then we use a point estimate, so p hat is So N equals 0.669 times 1 minus 0.669 times 1.645 divided by 0.02 quantity squared. Okay? That would give you a sample size of, I would say, 1498 is prettier, but 1499 or 1498. I would actually, in that case, that decimal's so small, I'd accept either. Okay? Now, they're asking, what if he does not use the prior estimate? So the only thing that's going to change is that instead of P hat times Q hat, we're going to use 0.25. Okay, which actually gives us a larger value. And ends up being 692 people, I guess, if we're talking people. Yep. All right. Again, that takes care of section 9.1, and I will see y'all Wednesday.